Good day, future LPTs. So, I hope that you have enjoyed and natuto kayo sa previous lecture or review videos natin. So, in today's review video, we will be learning about thermal expansion. So, it is one of the topics in thermodynamics. Have you ever wondered why do the mercury in a thermometer rises? One factor is mainly due to the variation of temperature. So, if the temperature increases, then the volume of the mercury inside the thermometer also increases. Kaya yung expansion of the mercury is correlated with the variation of temperature. So, the same with the concept in the concrete bridges. Diba? Bakit kaya nagkakaroon ng crack ang bridge? So, isa lang sa mga factor kung bakit nagkakaroon ng crack ang bridge is mainly because of the amount of heat na absorb ng bridge. If that amount of heat is too much na, masyado nang marami na surpass niya na yung limit na kayang i-tolerate ng bridge, then it will crack. Why? Kasi 'di ba yung atoms or molecules ng concrete, 'di ba? Stiff 'yon. So once na nagkaroon ng breakage, hindi mo na may babalik 'yon, unlike sa water and air. So bakit nga ba nagkakaroon ng breakage? Kasi 'di ba kapag yung heat or ay napakataas sa isang concrete, the atoms will have in aggressive movement. So aggressive yung behavior ng atoms. So dahil umaalis sila in their positions, so it might cause cracks. So yun yun. So this is one of the main purposes or importance of thermal expansion. So it is not only in engineering but could be also applied in medicines and in others. So during thermal expansion, nagkakaroon ng metamorphosis sa spaces between the particles or the molecules. So nagkakaroon ng maliit na pagbabago sa pagitan ng mga particles. 'Di ba nga kapag tumataas yung temperature, nagiging excited yung mga particles. Kaya kapag na-reach na neto yung limit, so nagkakaroon din ng paglayo-layo between those particles. So the molecules of a solid is in fixed equilibrium position. So solid matter is stiff. Rigid ang particles ng solid matter. Stiff to. Nasa fixed position lang sila. So hindi sila hindi ito nagfi-freely flow, unlike the gases as well as water. So kapag nag-crack ang solid object, hindi na to may babalik without using adhesive, 'di ba? Without using paste or other na pandikit. So the molecules of a liquid matter can be separated and restored. So the molecules of a liquid matter is more free to displace. Na kaibang-kaiba nga talaga sa solid. Kasi ang matter, kahit maghiwa-hiwalay yan, magdidikit din agad yan. Pwede silang ma-restore ulit yung shape depending on the vessel, unlike solids. Kaya napaka-importante ng concept ng thermal expansion in solids. So the atoms are the particles connected by springs to their neighboring atoms. If an atom is pulled away from its equilibrium position, the distortion of the springs provide a restoring force. So, may imaginative spring na nag-hold between these atoms para hindi sila mag-break or mag-separate sa isa't isa. So, kahit na magkaroon ng thermal expansion in a solid or between these fixed atoms, 'di ba? Kahit na magkaroon ng change of space, hindi naman agad-agad na nagbe-break 'yun because of this spring. Na-stretch pa 'to, and um na after bumalik ng temperature to its normal state, babalik din naman ang um, volume ng object. So hindi naman porket na naka-experience ang isang object ng thermal expansion, magkakaroon agad ng breakage. So, depende yun sa limit na naabot niya. Pero kapag naabot niya yung point na kung saan is hindi na kayang hold ng spring yung excitedness ng particles, dun lang magkakaroon ng breakage. Pero as long as it can hold, then it will restore back from its original volume. At a temperature above room temperature, the atoms of an object vibrates around its position. As the temperature rises, the amplitude of vibration also increases. That causes greater separation between the atoms. So, may direct relationship ang pagtaas ng temperature sa paglakas ng vibration ng particles. And kapag lumakas ang vibration ng particles, tumataas din ang tendency for its separation or its breakage. So, kapag bumalik naman to the normal temperature or tinatawag nating room temperature, then magre-restore ulit ang volume ng object. Kasi mawawala or hihina yung excitedness or yung vibration ng particles. So, there are three types of expansion, thermal expansion. We have the linear expansion, the aerial expansion, and lastly, the volumetric expansion. So, these three differentiate from the axis that they are expanding of. So these axes are what we call dimensions. So sa y-axis, that is the height, x-axis, that is the length, and the z-axis is the width. So yun. So kapag linear lang, isang axis lang siya, it could be y-axis lang or x-axis lang. Kapag aerial, two axis, could be the y-axis and x-axis lang. And the volumetric is having three dimensions na involve yung y, x, and z axis, or the length, height, and width. So the change in length compared to original length is called linear expansion. It occurs in a solid matter, and the coefficient is alpha. So in linear expansion, one dimension lang ang nagbabago or nagtatransform yung shape ng object. So kung as you could see from the GIF, 'di ba? Yung haba lang, yung length lang ang nagbabago ng shape. So depende sa object din kung gaano yung um, amount ng heat na kaya niyang i-hold and gaano kalaki yung effect sa kanya ng heat na yon. So, kagaya na lamang dito sa example, they have experienced the same amount of heat, but the fine ceramics changes lesser than the metal steel. Meanwhile, the change in area compared to original area is called areal expansion. It occurs in a solid matter and the coefficient is 2 alpha. Now, bakit naman na siya 2 alpha? Because dalawa na yung, or times 2 alpha, because dalawa na yung dimensions na involved. It could be the height and the length, or the height and the width, diba? So, yun, 2 dimensions na yung natatransform in areal expansion, as you could see here in the figure. So, yung original shape niya is yung the red portion. And nung naka-experience siya ng certain amount of heat, nag-change yung dalawang sides ng shape. So, nag-increase ang area nito. So, ayun naman yung pink portion. And lastly is the change in volume compared to original volume, and it is called the volumetric expansion. So it occurred in a solid or liquid matter. So the coefficient for solid is 3 times alpha, while the coefficient for volume in water is beta. So dito lang nagkaiba sa volume, kasi kapag solids ang mini-measure natin is 3 alpha ang gagamitin. And kapag liquid is beta. Now, why is it 3? Because it involves 3 dimension. It involves the length, width, and height. So as you can see from the GIF, di ba? It is a water or a liquid substance. So when the temperature rises and the object have absorb the temperature or the heat, so it gradually changes its volume. So yun nga, as you could see from here, nung tumaas yung temperature, nag-increase din yung volume ng water. And because of the separation of the particles. So in thermal expansion, it is directly proportional to the change of temperature. So basta nagbago yung temperature, or kapag tumaas yung temperature, mag-i-increase ang volume, area, and length of an object. Pero kapag bumaba naman yung temperature, in solids, it will return to its neutral state or the normal state. Pero sa liquid naman, kapag bumaba yung temperature, magiging rigid yung particles, turning from liquid to solid. So, the following are the formula for each forms of expansion. So, in linear expansion, the formula is change of length is equal to original length multiply to alpha coefficient multiply to change in temperature. Meanwhile, in area expansion, so the formula is change in area is equal to original area multiply to times 2 or twice the coefficient and multiply to change in temperature.
Meanwhile, in volumetric area, so dito ang ginamit natin is water, di ba? So the formula is change in volume or change in initial volume is equal to original volume multiply to beta multiply to change in temperature. So the following are the value of each symbol. So theta L is represents the change in length. Theta V represents the change in volume. Theta A represents the change in area. A0 or AO represents to original area. VO represents to original volume. LO represents to original length. So these three are the neutral neutral volume, area, and length of the objects. So alpha is the coefficient of thermal expansion in solid substance. Beta is the coefficient of thermal expansion in a liquid substance. And lastly, the theta T is the change in temperature, which is very important kasi kapag hindi natin nakita ang theta T, so I don't know if how could we discover the change in or the thermal expansion. So the following are the equations for thermal expansion. So the equation for change in length is change in length is equal to original length multiplied to solid coefficient multiplied to change in temperature. So next is change in area. So change in area is equal to original area multiplied to twice the alpha and multiply to change in temperature. So change in volume in solid, so change in volumes of the solid, kaya Vs is equal to original volume multiply to 3 alpha, thrice the alpha, multiply to change in temperature. Lastly is the change in volume in liquid. So the formula is change of volume in liquid, kaya VL, is equal to change in volume in original or the change in original volume, then multiply to beta, then multiply to change in temperature. So this is the table for average coefficient expansion for multiple substances or different substances. So in the first set, ito yung mga solid substances, while the second set or the second column is the liquid substances and gas substances. So first we have the aluminum substance. So automatically its coefficient is alpha kasi solid yan. So depending on your application, it could be multiply to 1 alpha or multiply to 2 alpha if it is aerial, or multiply to 3 alpha if it is volume. So aluminum has a average linear coefficient of linear expansion na 24 raised to negative 6 over degree Celsius. So ang unit natin is over degree Celsius. For example, brass and bronze has a coefficient of 19 raised to negative 16 over degree Celsius. For example, copper has a coefficient of 17 raised to negative 6 over degree Celsius. So as you could see here, ang ginamit natin para hindi na masyado malito, negative 6 na lang yung power sa lahat ng solids. Meanwhile, in liquid, lahat na negative 4 and in gases is negative 3 para hindi siya masyadong nakakalito. So bakit nga ba mas mataas ang power ng solids? 'Di ba pag negative is much lesser. Habang tumataas ang number, bumababa ang value. For example, negative 1 is higher than negative 6. Yon. Now, ang solid kasi mas less ang thermal expansion than the liquid and comparing to gases. Kaya negative 3 yung gas kasi kapag naka-experience to ng certain amount of heat, mas malaki ang expansion niya compared to liquid and the solids. So this is the a sample problem. The problem is a steel railroad track has a length of 30 meters when the temperature is 0 degree Celsius. Now, what is the length on a hot day when the temperature is 40 degree Celsius? So, ang hinahanap dito is yung expansion ng railroad track nung naka-experience to ng hotter temperature from 0 degree Celsius to 40 degree Celsius. So, first, ang gagawin natin is computing the length. Diba? So, ang solution, ang formula natin, dahil nga length, ang kinukuha natin is ang dimension lang. So, change in length is equal to, original length multiply to alpha coefficient multiply to change in temperature. Dahil nga 0 naman ang original temperature and 40 degree ang final temperature, so 40 subtracted by 0 is 40. So, nung pinag-multiply natin yung coefficient, length, and change in temperature, so we could cancel the degree Celsius from the coefficient and the temperature. So, yun, na-cancel na yung Celsius. Kaya ang may iwan na lang ay meter. Ngayon, makukuha na natin yung change in length. So, 11 raised to negative 6 degrees Celsius multiply to 30 meter multiply to 40 degree Celsius is equal to 0.013 meter. Now, next, we will get the final length. Yung sa 1, kinuha lang natin yung change in length, pero dito final length na, yung kabuohang length na nung railroad track. So, dahil na-expose siya sa 40 degrees Celsius, add natin yung original length ng railroad track plus the change in length. So, 0.13 ay 0.0013 meters plus 30 meters is equal to 30.0013 meters. So medyo ano lang naman, hindi naman kalakihan yung thermal expansion na nangyari dito sa railroad track. So, pero kahit sabihin nating maliit ang changes within them, so basta nagkaroon ng crack yan, mahirap nang ibalik yung solid or rigidity ng object. So, yun.
So I hope natuto kayo about thermal expansions. So your learnings are not just for the review purposes but also for instruction. I hope na antabayanan nyo pa yung other review videos para makapasa tayong lahat. So that's all. Thank you. Please like and subscribe to my YouTube channel as well.